Hello everybody, my name is Hongda Lin.
My name is Wang.
So this is the final project for CSE 5544. Our topic is VAST Challenge 2019 with Mini Challenge 1 as our topic.
So the background of the topic is that Hammer has been hit by an earthquake, which leads to huge damage to the city, and dispatching limited resources to this area is a major challenge. So the head-on questions here is, with given data, how to propose a visualization system that provides enough information for properly dispatching resources. Next slide, please.
For the dataset, the software we're using in this project are D3, Pandas, and Python. And the visualization we are dealing are scatter plot, heat map, histogram, and radar chart. For the scatter plot data, we process the data into CSV file with time as indicator, record the report value at each location. For the heat map data, we process the data into JSON file. In a JSON file, we have a recursive data structure with location ID as the parent and each date as children. The date itself is also the parent and with different information as children. The information node contains all the data we need to construct a heat map. For the histogram data, we process the data into CSV file with location as indicator, record the infrastructure damage value associated with this location. For the radar chart data, we process the data into CSV file too, with location as an indicator and the resource dispatching distribution associated with this location. Here is an example of the data we processed.
So there are four analytical questions here. The first is, within the given timeline, when and where are the most earthquake reports happening? And based on question one, how is the infrastructure damage value at each location at that time? And third question is, how is the average infrastructure damage at each location after the earthquake? And the final question we like to ask is how to dispatch resources properly to each location after the earthquake. Next slide, please.
Here is the final result for our first question. The question answered here is within the given timeline, when and where are the most earthquake reports happening? For the visualization design, we choose points as our marks, vertical and horizontal points colors as our channel. We place the visualization at the upper left in the final visualization, and the interactions we're using here is the user could select different locations from the checklist, scroll up and down to zoom in or out. For the visualization requirement, we use the scatter plot to show when and where has the most number of earthquake reports. Based on the number of reports, we may pay more attention in analyzing this location. As we can see from the visualization here, location 3 have the most number of earthquake reports, and we are paying more attention to location 3 in the later visualization.
So the second question is, how is the infrastructure damage value at each location at that time? And here we use the heat map to visualize it, and the visualization design here for marks with its lines, and for channels its vertical and horizontal positions and colors. We put it on the upper right of the final result, and the available the interactions you can use here are select different locations from the drop down, and you can also click on the map to see data in a smaller time scale. scale. So we use it to visualize the average damage value for each location at a given time. And by click on the big rectangles, you can get the average data, the similar average data for a smaller time period. Next slide, please.
So for the final result for our histogram, the question answered here is how is the average infrastructure damage at each location after the earthquake? So for the visualization design, we choose lines as our marks, vertical lines and horizontal positions as our channel. We place the visualization at the bottom left of our final result, and the interactions we're using here is the user could select different locations from the dropdown, and when the user places the mouse on the bar, a tooltip will show the average damage value. So for the visualization solution, we use multiple histograms, each for a specific location, to visualize the average infrastructure damage of all types at each location. So besides using heat map to analyze the damage at each location, we have more ways to provide visualization to determine the overall damage.
The last question is how to dispatch the resources properly to each location after a quick earthquake. And here we use a radar chart to visualize the decisions. And here the visualization designs include lines and points for as marks and positions along each axis and colors as channels. And we put it in bottom right of our final results. And as for interactions, you can select different locations from the checklist, and there will also be tooltips so shows the resources dispatching proportion, and the solution is a radar chart with each axis as proportion of resource dispatching distributions of different infrastructure type, and one can select locations from the right checklist. With this chart, one can intuitively understand what resources each location needed the most. Next slide, please.
So our final result is here. The visualization result is as expected, and we have come up with the following conclusion: that power requires the most resource dispatching among all the infrastructure, and the second one is location 3 requires the most resource dispatching among all the locations.